right, we talked about obviously what was a rational function, which is just one that has the fraction in it. So it's going to have a fraction built into it. Okay, we talked about how to find domain. So remember, we're looking for the denominator not equal to 0 because you're not going to get the square roots and stuff in this part. And then we talked about how to find the vertical asymptote, which is setting the denominator equal to 0, and then the horizontal asymptote. There was 3 scenarios for horizontal asymptote. What happens if the highest exponent in the top is smaller than the one in the bottom? If the highest exponent in the top is smaller than the one in the bottom? Y equals 0, good. What happens when it's bigger? There is none. What happens when they're the same?
It's the leading coefficient.
Good. Leading coefficient at the top over leading coefficient at the bottom. And that's kind of where we left off yesterday, right? We talked a little bit. So here's the domain. Here's the horizontal asymptotes. We talked a little bit about holes yesterday. So now that we're going to train ourselves, we didn't actually start this way because we hadn't talked about it yet. But now we're going to train ourselves to look for holes from the very beginning. So when you get your function, the first thing you're going to do is factor whatever you can. So you're going to factor the numerator, you're going to factor the denominator. The domain comes from before you cancel out. So the next thing you do is domain. Find your restrictions on domain. Then comes, can I simplify this? And if you can cancel through one of your factors, that's what I mean by simplify, then you're creating a hole in your graph. Not only are you changing what your graph looks like, because it's no longer the same rational function, you are also creating a hole in your graph. And this is where we were talking about yesterday that you have to be smarter than your calculator because your calculator will not show a hole. If it was an example like this, it would show the straight line. So it will adjust it to be simplified, but it will not show you the hole. So you've got to know to look for it. So on the test, like obviously now that we're in the homework, you're going to look for things like holes. But on the test, same thing. You're going to start to train yourself to go in that order. So from here on out, when we graph all the way through, we'll always check, okay? Because if not, you're plugging right along, you get all the information, you think you have a graph, and it's not the right graph, okay? So you want to be really, really careful. So again, a hole is created where something would cancel from the denominator, not necessarily the top. It's going to cancel from both places. But it's because we're canceling it from the denominator that makes it the hole. So wherever that is, I would set that equal to 0, and that's the x value of the hole, which is what WebAssign asks for. If you want to know the exact location of the hole, which you're going to need on your graph, you're going to plug that value back into your simplified equation, and then you'll get the y that coordinates with it, okay? But we're going to practice that today. So this is how your book obviously stressed. This is how they recommend that we graph. I'm going to highlight a couple of things here or there, okay? The first thing I said, like before, the first thing you want to do is factor whatever's there. So I would start by factoring both my numerator and my denominator. Then I would say that's number 1, okay? If it asks for domain, you're going to check for your domain, and I would say that's 2. 3, check for holes. So again, if you can cancel something out. Then I go vertical asymptotes. So the 4 is actually the 4. I go 5, horizontal asymptotes. I look for intercepts. So like 6 and 7, find your X and Y intercepts. And then this step, which I'll call 8, is needed like if you don't have enough information from what you've already gotten. So we're going to find all those things. You're going to graph what you have before you get to 8. And then if you don't know what your graph looks like in between the asymptotes, that's when 8 comes into play and you're plugging in a point. You're going to usually at least plug in 1 point, okay? But your intercepts can also help you here. Number 1 is obviously something that could be helpful because of the symmetry. So if you know it's supposed to be symmetric, it's only going to be either the y-axis or the origin because otherwise it would fail your horizontal or your vertical line test and then it's on a function, okay? But if those cases, if one of those happen, if I plug in an x and it cancels completely out, or if I plug in the x, it changes all the signs, including the one on the other side, the equal sign, then I've got symmetry, and that will help me determine what my graph should look like. If it's symmetric to the y-axis, then whatever's happening on the right has to happen on the left. And if it's symmetric to the origin, it's going to be like a diagonal shape, okay? But again, when we go through there, I'll kind of pinpoint that when we're talking about it. I won't ask for explicit symmetry. It won't be a line on your test. Everything else that's there will be a line on your test. It's going to say, give me the domain. It's going to say, give me the both sets of asymptotes. It's going to say, find the intercepts. And then it's going to say, graph what you need from there. All right, so we're going to go all the way through this process from the start. It just says graph using the 7-step strategy from the previous slide. So we're going to start by what? What did we say step 1 was? Factor. Is there something you can factor in the top or the bottom? No, okay? Which means I can even look at it now and say, is there something that will cancel out to give me a whole? No, right? So I know that gets eliminated from this section. So if that's a test question and it says whole, you would just write none. Okay, same thing in the homework. I think it's D and E. So then the next step is find your domain. So domain comes from the denominator. This cannot equal 0. So x cannot equal 2. And my domain would be negative infinity to 2 and 2 to positive infinity. If you go straight to vertical asymptotes after that, all you have to do is change that not equals to an equals. And it's x equals 2. So again, if you're going from domain to vertical asymptote, all you got to do is change the not equals to an equals. Then we go horizontal asymptote. So what's the highest exponent in the numerator? 1. What's the highest exponent in the denominator? What's that relationship? Good. They're the same, so it's a leading coefficient one. So it's y equals 5. Again, vertical asymptotes, x equals. Horizontal asymptotes, y equals. You don't want to forget that. That's a silly way to lose points. Okay, then I'm going to go the Y-intercept because that's the next easiest thing. And for the Y-intercept, we would normally plug 0 in for x. So I would take my function over here, and I would get y equals 5 times 0 over 0 minus 2, and I get 0 over negative 2, which is what? 0. Then I go X-intercept. And to do that, we set y, or we plug 0 in for y. What's your first step when you're solving with the fractions like that? Multiply by the bottom. What's always going to happen when I multiply the other side by the bottom? It's going to get rid of the denominator. It's going to get a 0. So when you're doing your intercepts, when you're doing your X-intercepts, you literally can ignore the bottom and just set your numerator equal to 0. Because that first step is always going to be to cancel out whatever's in the bottom, and it's always going to go away. So then I would get x equals 0, which makes sense from what we know. If I have a y-intercept of 0, 0, I should have an x-intercept of 0, 0 as well. We said already there's no holes. And we're going to get to the last thing would be slant asymptote, which we'll get to in a little bit. All right, so now we're going to plot all this information that we've got. We're going to make a vertical asymptote at x equals 2, which is a dashed line through 2. We're going to make a horizontal asymptote at y equals 5. If I want to do a quick check for symmetry, there would be none. Okay, if I plug in a negative x, it doesn't go away. It changes the sign on the top and one of the terms on the bottom, but not all of them. So the only other piece of information I have is a plotted point at 0, 0. So now usually, and there are exceptions to kind of like all these kinds of graphs, but usually when it's not an x squared, these are going to take place in corners. So it'll be top corner, bottom, like top right, bottom left, or top left, bottom right. We already know it's going bottom left, right? I have a point that is underneath that horizontal asymptote, so I know my curve is doing something like that. It doesn't have to be perfect. We obviously have one plotted point in there. It has to pass through that one. But so far, I don't have to be 100% yet. I think it's going to go above my horizontal asymptote on the right-hand side, but to be sure, I'm going to plug in a point. I want to plug in a point that is to the right of this vertical asymptote. I already have one to the left. That was my intercept. Now I want to plug in one to the right, and I want to make life easy on me. So I'm going to pick the smallest one, which is 3. I'm going to plug in 3. And I get 15 over 1, which is 15. So when I plugged in 3, I got 15. Is that point above or below that horizontal asymptote? It's above. And it's so high that it's not on this graph. This is another one of those scenarios where I don't care if it's perfect. You're going to plot it and label it to tell me where it is. And then I know my graph goes, well, let me make it the same color as the other one. In the other direction. So again, when there's only one vertical asymptote, when it's not a squared, and there's only one vertical asymptote, it usually goes corners, top right and bottom left. If there was an x squared in here, they're usually in the same direction, both up or both down, okay? They follow on the patterns of their parent function. Questions on that one? All right. Starting where? Factor. This time I can factor the denominator, right? This would be x plus 5 and x minus 5. Can I cancel anything? No, which means I already know that there's no holes. My domain would be that neither of these can equal 0. So x cannot equal -5 and x cannot equal +5, which would be -infinity to -5, -5 to +5, +5 to +infinity. My vertical asymptotes are the exact opposite of that. X equals -5 and x equals +5. You can write plus or minus as long as you graph both. It doesn't matter. What's the relationship between the highest exponent at the top, highest exponent at the bottom? They're the same again. So this is my leading coefficient, which would be what? Good. Y equals 2. Then I go X-Intercept or Y-Intercept, doesn't matter. Y-Intercept. I'm going the same order I went last time. So that would be 2 times 0 squared over 0 squared minus 25. And I get 0 over -25, which is 0. For my X-Intercept, I'm going to plug 0 in for Y. And I'm going to ignore the denominator because we said that first step would have been to multiply by the denominator. It's going to cancel out. So I get to this step. What would I do next? Divide by 2. And I get x squared equals 0. And then what? Square root. What would normally go in front of my square root? Plus and minus. Why is that important? It bounces. So all the things we know from before carry over. There's a multiplicity of 2 on that 0, which means it's going to bounce off of that point. Okay? So let that help you, because again, that eliminates an extra plotting of a point, right? So I know my X-intercept is still 0, 0, but I would put a little note for myself to remind me that it's going to bounce. This is also when symmetry will come into play and be helpful. If I were to plug in a -x here and a -x here, both of those are going to cancel out, which means this is symmetric to the y-axis. Everything that happens on the right of my graph is going to flip over and happen on the left. With me so far? Okay, now we plot these things. So I start with my vertical asymptotes at -5, +5. My horizontal asymptote at y equals 2. My x and y intercept at 0, 0. Now, I said it yesterday, but I want to repeat it because it's important. Your graph, when you have two vertical asymptotes like that, so it's divided into 3 sections, can pass through the horizontal asymptote. So I could have a shape that's kind of like the cubic function that runs through the middle. But if that's true, is this graph symmetric to the y-axis? No, which means this is one of those graphs that's going to have a parabola shape in the middle. And when it does that, the outside curves go in the opposite direction. Because it has to be symmetric to the y-axis. So let's say you're not the best at symmetry. How else am I going to figure this stuff out?
How do you know it went down though?
Because if
It can't cross.
it can cross your horizontal asymptote, but in order for it to cross your horizontal asymptote, it takes on that cubic shape. So it goes up to one side and down to the other. Yep. But I'm going to pretend like we don't know that stuff. Like, let's go back 30 seconds and pretend like we didn't know it. How would you figure out what this shape looks like? Plot some points. So I'm going to plot a point that's to the right of my first asymptote. I already have a point in between, but you can definitely plot some extra points there if you wanted. I could plot 1 and -1, okay? And then I have to either plot the point to the left of my furthest left or know that this is symmetric to the y-axis, so it repeats that behavior, okay? So if I plug in +6, I would get 2, 6 squared over 6 squared minus 25. 2 times 36 over 36 minus 25. 72 over 11. Which is 6 and 6/11. Is that above or below the horizontal asymptote that's on the left? Well, the horizontal asymptote. It's above, right? My horizontal asymptote is at 2. So 6 and 6/11 would be somewhere up here. 6. Which confirms that that curve goes above the horizontal asymptote. Yep.
And you knew it was towards the top because it was squared, right?
I knew it was towards the top. I mean, yes, but if you don't, then you put the point in.
Okay.
Yep. Because it has to be symmetric to the y-axis in this case. We plugged in a -x. Both of them went back positive.
Yeah, but the other two.
So they can't. You're gonna never get all 3 that point in the same direction. Is that what you mean? Like, how do I know that it doesn't do this, this, and this? That never happens.
Okay, but how do I know it doesn't go on the top right and the bottom left?
Because it's got to be symmetric to the y-axis. So if I don't know symmetry, then I'm gonna plug in my -6. So I get 2 -6 squared over -6 squared minus 25. And I get the same answer I got before.
Wait, how do you know the parabola downwards again?
So you're going to start to learn this more. But if it's symmetric to the y-axis, it has to take on a parabola shape. And a parabola shape will never pass through your horizontal asymptote. The cubic shape will pass through your horizontal asymptote. Can. Doesn't necessarily always, but can. And I knew it bounced, right? I knew it hit that 0 and turned around the other way. Yep. That's how I knew it was a parabola over a cubic shape, is I knew it had to bounce. So if you don't, and this is where time is going to save you or hurt you, right? This is where it's going to hurt your time or not. If you know things like symmetry, it's going to save you time on a situation like this, okay? If you don't, that means you're plugging in extra points. So this is one of those tests where I would say you plot as much as you know. The graphs are the last 2 kinds of questions, okay? You plot as much as you know, and then if you need to go back and plug in some extra points to be sure, you plug in some extra points to be sure. But you get through both graphs before you go back and start plugging in some extra points.
Could you just say that the two at the top are You
it's,
have to know it's symmetrical.
well, but those are the same, those are synonymous, right? If it is squared, it is symmetrical. If it's symmetrical, then you, yeah.
Oh.
Yep. All right, the last kind of asymptote is called a slant asymptote, and it is a line, okay? It is a line that is not vertical or horizontal. It has some sort of slope. It could have positive slope, it could have negative slope, but it has some sort of a tilt to it. So the slant asymptote happens when the exponent in the top is 1 more than the exponent in the bottom. So this happens when the exponent in the top, or the degree of the numerator, is 1 more than the degree of the denominator. Which means you can't have a slant and a horizontal. It's one or the other, or neither. Because if the one in the top is more than 1 bigger, then it won't. So you can have a vertical and a horizontal. You can have a vertical and a slant. You cannot have a horizontal and a slant. The way we find the slant asymptotes equation is by dividing your numerator by your denominator. Sometimes you can do it synthetically. Sometimes you have to use long division. And then finding you literally take the quotient and ignore the remainder. So if I was to take and divide, I don't know, x squared plus 2x plus 1 by, let's just say it was x minus 3. I would divide into that, and then whatever's at the top, ignore my remainder. I'm going to set it equal to y, and that's my slant asymptote. So you ignore the remainder, you take the quotient at the top, you set it equal to y, and that is the line that is your slant asymptote. All right, so example 6 just literally says find the slant asymptote of the function. The numerator's exponent is 1 more than the denominator's. That's how I know it has a slant asymptote. Yep.
Isn't if it's bigger though, like that?
That there's no horizontal.
Oh, okay.
Yep.
Okay.
Yep.
Got it.
That's how I remember the 3 scenarios of horizontal. I say slant has to be 1 more, and if it's 1 more, it can't have horizontal. So, like, horizontal doesn't exist.
Right.
That's how I remember it.
Okay.
Yeah.
Thank you.
You're welcome. Okay, so again, 1 in the top is 1 more than the 1 in the bottom. So I'm literally going to take the numerator here and divide it by my denominator. It's missing a term, so I'm going to get the x plus 0 there. And divide. So first into first would be x. Multiply that by both on the outside. Change your signs. This cancels as it should. 6x. Bring down the 2. First into first again. Multiply by 6. Both on the outside. 6x plus 0. Change your signs. This cancels. I don't need that remainder. That remainder is not important to the to the slant part of this, which is what we're trying to find. So this I ignore as long as those first ones cancel out. Otherwise you did something wrong. And I set my quotient equal to y. And that's my slant asymptote. So this slant asymptote is going to be a line. If I wanted to plot that, I would start at positive 6 and have a slope of 1, up 1 and down 1. Up 1 and right 1 or down 1, left 1. And that's where my asymptote is going to go. So there are times in which like you don't have a vertical and a slant, okay? But for the most part, you're either going to get a slant and a vertical, or you're going to get a vertical and a horizontal. So the test will have that kind of combination. One with horizontal and vertical, and one with slant and vertical.
So if it after the asymptote,
Yeah.
that's right.
Y equals x plus 6. Yep. You're welcome. Questions on that one?
So there could be a slant and a vertical?
Yeah, and usually there is. Usually it's not you only get one. And what happens with these is usually, so I got a vertical and I'll get a slant, and these graphs occur in corners, like that, or that, and that. So they occur in opposite corners. I won't walk all the way through this graph, okay, because there's not zeros that you can find. You'd have to use the quadratic formula to find, okay? But think about what it would look like to have a slant asymptote, right? So my slant asymptote would be a line. It would be y equals x plus 6, which means I'd go up to the 6, plot my y-intercept, and then use my slope to get my line. So this would be the slant asymptote. My vertical asymptote would come from the bottom being set equal to 0. So I'd have a vertical asymptote at 0. And then graphs with slants and vertical go in opposite corners. It would either be here and here, or it would be here and here. So I'd have to either have an X-intercept or a Y-intercept that would be plotted to be in that corner, or I would plug in the point from the right and the left of the vertical asymptote, okay? Again, this one is not, like the top's not factorable. Otherwise, we'd work through it. But that's what a slant would look like. All right, you find this one. Find the slant asymptote. All right, so when I divide, well, first of all, again, you want to identify that there was a slant. Obviously, it told you it was a slant. So, but even if it didn't, you would want to know that the one in the top is one more than the one in the bottom, which is why there's a slant here, okay? The exponent in the top, one more than bottom. So when I divide this, the numerator is missing a couple of terms, right? I'd have to do x to the third plus 0x to the second plus 0x minus 1 divided by x squared plus 2x plus 2. Then I would start my division. So first into first would be x, multiply that. X to the third plus 2x squared plus 2x. Change your signs. Cancels. Negative 2x squared minus 2x. Bring down the 1, negative 1. Multiply again. First into first would be negative 2. Distribute negative 2x squared minus 4x minus 4. Change your signs and just make sure the first thing cancels. If it does, you can completely disregard your remainder because what's important is up here at the top. Y equals x minus 2 would be your slant asymptote. Questions on that one? Train ourselves to include slant asymptote into our tests. So, which is what's going to happen on your actual test. It's going to ask you for domain, for horizontal, for vertical, for a horizontal asymptote, vertical asymptote, slant asymptote, holes, X-intercept, Y-intercept, and then you're going to do any additional points that you need. So we're going to practice from here on out. So step 1 was what? Factor it. The numerator this time would be x minus 4 and x minus 1. Factors of positive 4 that sum to negative 5. Denominator x plus 2 and x minus 2. Does anything cancel? No, so there's no holes. Okay, again on your test you can put none, you can put D and E, I don't care. On WebAssign it's D and E. Now I'm going to go, it doesn't say it, but I'm going to go domain just so we get the practice of it. Domain, it was not equals to 0 here. So x cannot equal negative 2 and x cannot equal positive 2. Negative infinity to negative 2, negative 2 to positive 2, 2 to infinity. My vertical asymptotes are the opposites of those. X can equal, x equals negative 2 and x equals positive 2. My horizontal asymptotes. What's the relationship between the exponent in the top and the exponent in the bottom? They're the same. So horizontal asymptote. Y equals 1. Leading coefficient of numerator, leading coefficient of denominator.
What happens if they're different in the coefficient?
If they're different, you just put one over the other. You're saying coefficient, right? Exponents, if they're the same, you just do the, so if it was like a 2 in the top and a 1 in the bottom, it'd be y equals 2.
But if it was 2 in the top and a 4 in the bottom?
Then you'd simplify that to be a half. So y would equal a half.
Oh, but it can be a fraction.
Sure.
Okay.
Yeah. Is there a slant asymptote? No. Exponent in the top is not 1 more than the bottom. And also remember, you can't have a horizontal and a slant. It's one or the other. Thank you. Okay, now I do Y-intercepts. So I'm going to plug 0 in for x. I would get 0 squared minus 5 times 0 plus 4 over 0 squared minus 4. These are gone. It's 4. This one's gone. Negative 4. That's negative 1. I actually think the homework says zeros instead of X-intercept. So I'm gonna put that one because I think the homework and I think the test says zeros instead of X-intercepts. But remember, those are almost the same thing except the zeros we list. So for the zeros, we set y equal to 0. Or we plug 0 in for y. Just using the numerator n because it's already factored, I can use that one. Split and solve, and I get 2 answers. X is 4 and x is 1. So again, remember zeros we list. If it had said X-intercepts, I would put it in coordinate point form. Still good? Is this symmetric to the y-axis? If I plug in a negative x2, does all the signs go back?
Yes.
Almost. Not on this one, right? So it's not symmetric to the y-axis, and it doesn't change all of them, so it's not symmetric to the origin either. So there's no symmetry to help us out this time. Now we're going to graph.
Would you have to would the bottom have to change the sign?
Yep, everything. All right, vertical asymptotes at -2 and +2. Horizontal asymptote at 1. No slant asymptote. Zeros at 4 and 1. Y-intercept at 0, -1. So what do we think is going to happen with this kind of shape? Just take a guess.
In the middle, it's going to do like that.
That cubic shape,
Yeah.
right? It's not bouncing off a point. There's no, I know what you mean. There's no symmetry here. So I'm guessing it's probably going to be that cubic function shape in the middle. What do we think is going to happen on the outsides? Good. Bottom right is definitely already a point, right? Which means this would be opposite corners. Okay, the only time they go in the same direction on the outside is if there's that parabola shape in the middle. So I think it's going to look like this, it's going to look like this, and it's going to look like this. But I am certainly going to do some more investigation before I get to that point. So I know the bottom right is going to go like this because it's not going to cross through my horizontal asymptote, and I already have 1 point there. So if I think it's going to go up in the top left corner, then I'm going to plot something in from back over here. So again, make it small, make life easy for you, like a -3. I'm going to plug in, and it doesn't matter if you plug it into the factored form or the original. So -3 squared minus 5 times -3 plus 4 over -3 squared minus 4. And I get 9 plus 15 plus 4 over 9 minus 4. This is 24 plus 4 is 28 over 5, or 5 3/5. So -3, 5 3/5 would be up here, which confirms what we thought that curve is going to do. Now I can go with my gut on the cubic shape in the inside, or I can also plug in one more point like -1. So if I plugged in -1,
Do you need those points?
no, not if you have at least 1 point from each range.
Oh, okay.
I just would be sure, and if I have the extra time, I would definitely check. 10, -3, -3 and 1/3. Questions on that one? Okay, I just added this on so that we could practice to see what it looks like if there's a hole. Okay? This will be fast. Don't worry. I'm not going to go through all the processes. I'm going to show you what happens when there's a hole. So first of all, I would factor the top and the bottom. Not Y, X. I need to change the sign. Sorry, hang on. I got to actually make the whole point of this work. So the X plus 1 is going to cancel. So there is a hole where X equals -1. Because if I set that equal to 0, I would get X equals -1. So now my equation becomes f of x equals x plus 1 over x minus 4. So domain comes before I cancel. Domain would be that it can't equal 4 and it can't equal -1. So this would be negative infinity, -1, -1, 4, 4, positive infinity. Domain comes before you cancel. My vertical asymptote comes after. So now this is the only one that is left, which means there is only a vertical asymptote at x equals 4. My horizontal asymptote, the exponents are the same, so its leading coefficient, which would be 1. My x-intercept, I would get 0 equals x plus 1, x equals -1, or my 0 is -1. And my y-intercept, I plug 0 in, and I get 0, -1/4. Yeah. The hole, that's where the x is. To find the y, I'm going to plug it back in. So to find the y coordinate of my hole, I take my simplified fraction, or my simplified graph, and I plug -1 in. -1 plus 1, -1 minus 4. Okay, so now I'm going to pull in the graph. I got a vertical asymptote at 4, a horizontal asymptote at 1, a 0 at -1, and a y-intercept at 0, -1/4. What do we think my graph's going to look like? Are they going to both go in the same direction? Is there symmetry? With symmetry, we would test from here after we simplify it. There's no symmetry, okay? So bottom left is definitely going to look like this. And top right is what we would assume. I would plug in like +5 to be sure. But there's a hole at -1, 0. So at -1, 0, there's actually a hole. So again, process for the hole is you want to obviously factor it from the beginning. See if you can cancel something out. If you can cancel something out, whatever got canceled from the bottom, set it equal to 0. That's the x value. And then you plug it back into your simplified function to get the y value. What could be left could be a line, like we saw like on the whole slide. It was a line. Or it could still be one of these functions, but you got to make sure you put that open 0, that open dot, wherever the hole is, okay? And again, the slant asymptote, because we didn't graph one of those. If you get a slant, you're going to get a vertical, you're going to get a slant. And those are always in opposite corners. So it will be like that and that, or it will be this and this. So the intercepts could help you find those, which corner it is, or you plug in a point. Same thing. You plug in a point from the right of the vertical asymptote, left of the vertical asymptote. This is a good chunk of your test. I'll be really honest because there's 2 graphs and they're worth a lot of points because there's a lot of parts to it. So tomorrow we'll do a class kick. We'll practice both of those, okay? But obviously 2-4 and 2-5 are still in your test, so it's not like you can forget about that stuff. The homework, remember that you are graphing everything by hand. And then if you want to use the graphing utility to verify, you can use the graphing utility to verify. So when I type this into my graphing calculator, I have to group the numerator and the denominator. If I have mine. I typed in the full original function, x squared plus, you have to group it. So I did this in the numerator, then divided by, and did that. You got to do them in parentheses so it knows how to group it, okay? And then I hit graph, and notice it gives me what I got, but you don't see the hole and you don't see the asymptotes, okay? That's normal. You will not see a hole and you won't see, like your graphing calculator is not going to draw the asymptotes for you. So it will resemble just the curved part of it, okay? So feel free, like I said, to use the graphing utility to verify, but you will not have your graphing calculator at all. You'll have no calculator at all on this whole test. So you need to make sure you know how to do all that stuff by hand. And when I grade this homework, I'm going to be nitpicky about making sure I see all the stuff that we've been doing, all that work, before you get a graph, okay? And then a hand-drawn graph. Then you make your selection from your multiple choice. Yep, hand-drawn graph, then go and pick your answer. But every single question should have a hand-drawn graph.